Hey, sixth grade. Today we're going to be looking at a bunch of different properties in math that are going to help us understand some principles in algebra. So our objective is I can understand that when a number replaces a letter, an expression or equation is stated. We're going to start with a little opening exercise where we have a bunch of equations listed out, and you can see this side uses the number 4 and this side replaces the number 4 with the letter G. So let's start out by just looking at this side here. So I'm going to cover up that side. If we only look at these equations, how many of these are true? Think about it in your head. All of them are true. How many of these statements would be true if we replaced the number 4 with the number 7? Think about it. All of them would be true. Would the number sentences be true if we were to replace the number 4 with any other number? Think about it. Yeah, these would be true, except if we replace the number 4 with the number 0, right? So 0 makes it a little bit trickier to think about, but any other regular rational number we could use. Okay, so a letter in an expression can represent a number, and that's what we see over here when I show you the letter G in these problems. When that number is replaced with a letter, an expression is stated. So if we replace the number 4 with the letter G and we wrote them all out, all of these are still true. And if we look at these a little bit closer, we can make some generalizations or create some properties. So for example 1, we're going to talk about the additive property of 0. This is an idea in math that tells us any number added to 0 equals itself. And we write that in algebra using letters. So G plus 0 equals G. Remember, a letter in a math expression represents a number. So can we replace G with any number? Yeah. I could choose any value for G, like 8, and replace G with that number. 8 plus 0 equals 8. 17 plus 0 equals 17. 35 plus 0 equals 35. 2,140 plus 0 equals 2,140. 1 million plus 0 equals 1 million. Will all values of G result in a true number sentence? Yes. So that's the additive property. Example 2, we're going to talk about another property. This one is called the multiplicative. So you know it has to do with multiplication. The multiplicative identity property of 1. That's the big idea that mathematicians use, and here's what it means. Any number multiplied by 1 equals itself. We would write that algebraically or using letters to look like this. G times 1 equals G. Remember, a letter in a math expression represents any number. We can replace G with any number and this would still be true. So 1 times 1 equals 1, 4 times 1 equals 4, 10 times 1 equals 10, 75 times 1 equals 75, 300 million times 1 equals 300 million, and that will always be true. That's the multiplicative identity property of 0. Example 3, we're going to talk about the commutative property of addition and multiplication. So this one looks like this. So the first row here is using all numbers. 3 plus 4 has the same value as when you do 4 plus 3, and 3 times 4 has the same value as when you do 4 times 3. So this works for addition and multiplication. You can switch them around and still get the same answers. And we can show that also using letters. So involving a little bit of algebra where we replace numbers with letters. So you can say a plus 4 will always equal 4 plus a. A times 4 will always equal 4 times a. I can plug any number in for that. So I could plug in 1. 1 plus 4 is 5. 4 plus 1 is 5. 1 times 4 is 4. 4 times 1 is 4. And you could test that out with other numbers if you wanted as well. We could even replace both numbers with letters now. So I have A and B, and it's still true. And now this means we could use any numbers for A and B as long as we plugged in the same number for A on each side, the same number for B on each side. A, B, and B. So what this property, the commutative property of addition and multiplication, tells us is that the order doesn't matter when you're adding or when you're multiplying. And example 4, we're going to ask a different kind of question. So if I replace all of these 3's that we see with the letter A, let's see what happens. So I'm going to rewrite this using a letter A every time I see a 3. So 1, 2, 3, 4. This is going to be A plus A plus A plus A equals 4 times A. And then this would be A divided by 4 equals A over 4. Okay, well that's still true. That's still true. When we chose a value for A and we replace A with that in each equation, it'll still be true. So if I say A equals 1, 1 plus 1 plus 1 plus 1 is 4, and 4 times 1 is 4. 1 divided by 4 equals 1 over 4. So this results in true number sentences. And any number, even 0 in this one, can be used in place of the variable A. So when we use letters in math problems, we would call them variables because they vary. They can represent any number. If I replace every time I see 4 with a B, this would also all still be true. Now, we can't have a 0 in a denominator, so unfortunately 0 won't work here. It would be undefined. That's what we would call it in math, but any other positive rational number actually would work. So those are all of the different properties that you need to be aware of and make note of when you're solving math problems. We have one little more piece. So I just want you to reflect on which property is easiest for you to remember and which one's the hardest for you to remember. And I just want you to write down like easiest, hardest, and then the names of the properties. So out of all of these properties, the additive, multiplicative, and then the commutative, which one is easiest for you to remember and which one is most difficult for you to remember?